if you compound, if you invest $1,000 at interest rate R compounded 4 times a year, then after 10 years you're going to have $1,000 times 1 plus R over 40 raised to the 40th power. And that function A is your amount as a function of R, the rate of at which the money is going to receive interest, okay, the interest rate. Okay, so what's the rate at which your amount after 10 years changes with respect to your interest rate? That is, okay, if you can choose different interest rates, and there are reasons for choosing different interest rates. Basically, the higher your interest rate, the higher your risk. So you want to balance getting a lot of money versus the risk of losing money. Okay, and that's a very complex decision, and we're not going to approach that. And there's no really, there's no formula for approaching that. You have to, every individual has to weigh risk. So we're not approaching the risk-benefit analysis. We're just saying, okay, if you choose a little different interest rate, you're going to have a little, you're going to have a higher amount at the end of the 10 years if everything goes as planned. So what does the amount, what's the rate at which the amount A of R you have after 10 years change with respect to the interest rate that you choose? Okay, so, well, that rate is just a rate of change of this with respect to R. That's the change in A divided by the change in R taken to the limit, and that's your derivative dA dr, which we also can write as A prime of R, where we understand that the prime is with respect, means the derivative with respect to the only variable present. Okay, so, and I'm going to use the prime again. We have $1,000 times 1 plus R over 4 to the 40th prime. What's the derivative? Well, we can factor out the $1,000, that's just a constant, and now we take the derivative of 1 plus R over 4 to the 40th. How are we going to take the derivative of that? Well, that's a composite. That's a 40th power of 1 plus R over 4. We can take the derivative of a 40th power function, and we can take the derivative easily of 1 plus R over 4 with respect to R. So I'm going to write that as f of g of R prime, where the breakdown is given here. Okay, 1 plus R over 4 to the 40th is f of g of R, where f of u is u to the 40th and g of R is 1 plus R over 4. It should be clear that if g of R is 1 plus R over 4, then f of g of R, you're going to replace the u with the g of R. It's going to be g of R raised to the 40th, and of course g of R is 1 plus R over 5th, so that's going to be 1 plus R over 5th, 1 plus R over 4 raised to the 40th power. So our f of g of R is this. You should understand that pretty well by now, having seen a lot of composites. Okay, and having worked, I hope, a lot of composites. Well then, to get the derivative, we got to know f prime of u and g prime of R, applying the chain rule. Okay, f prime of u is, well, just the derivative with respect to u now. That's going to be, that's just a power function, u raised to the 40th power. The derivative is going to be 40u to the 40 minus 1, 40u to the 39th. And g prime of R is even easier. Derivative of 1 plus R over 4 is just 1/4, and that's very straightforward. So, and if you don't understand that, you go back and work some more problems, because you really need to be able to understand these derivatives at this point. Okay, so that's going to be then $1,000 times your f of g of R prime, and that's going to be $1,000 times g prime of R times f prime of g of R. G prime of R is 1/4, so here's our 1/4 representing the g prime of R. And our f prime of g of R is going to be 40 times g of R to the 39th, plugging g of R in for u in the f prime function. And then, of course, g of R is 1 plus R over 4, and we get our final expression, $1,000 times 10 times quantity 1 plus R over 4 raised to the 39th power. and then multiplying the $1,000 by 10, we get $10,000 times 1 plus r over 4 raised to the 39th power. This function tells you the rate at which the amount you expect to get in 10 years, if everything goes well, changes with respect to r. So if r is 5%, you could evaluate this for 0.05. Okay, and it tells you if you change a little bit from 5%, how much the change is going to be. Well, it gives you the rate of change. If you change a little bit from the 5%, you can then use the rate of change and the change in R to figure out the change that you would have in the amount. At this point, this is simply another illustration of the chain rule and how the chain rule arises naturally in all kinds of contexts.